Alright, good morning. We are moving on to solving exponential equations and inequalities. Alright, so the big property that we need to know to do this is called the property of equality. And it says that if b to the x is equal to b to the y, then x equals y. So basically, the bases need to be the same. Okay, and that's usually our first step. And then our second step is then set the exponents equal to each other and then solve. Alright, so in example 1, we have 2 to the x and 8 to the 3. So somehow we need to make these bases the same. So a lot of times I'll start with the lower number, which is our 2, and I'll see how I can write 8 in terms of base 2. So we know that 2 to the first is 2, we know that 2 squared is 4, and I know that 2 cubed is 8. So basically 8 is the same as 2 cubed, and I'm going to rewrite it as 2 to the x is equal to 2 cubed, okay, because 8 is 2 cubed, so you just substitute 8 for 2 cubed. Alright, and then I'm just going to simplify what I got. So I got 2 to the x, and we go power to a power, so you multiply the exponents, so it becomes 2 to the 9. So now we have same base, alright, both base 2 here. So you just set the exponents equal to each other. So x equals 9. And that's our answer. So basically what it's saying is 2 to the 9th is the same as 8 cubed. Okay. Now our next one, I have 9 and I have 3. So again, I like to start with the lower number. So again, we know 3 to the 1 is 3. 3 squared is 9. Awesome. So we don't have to go any further from there. So I'm going to substitute 9 for 3 squared. So I have 3 squared instead of 9. 2x minus 1 is equal to 3 to the 6x power. So I have to do the power to a power property, so I have to distribute this 2 through. So I'm going to get 3 to the 4x minus 2 is equal to 3 to the 6x. So again, you see that our bases are the same. So I can ignore the base now and just solve the exponents. So I get 4x minus 2 is equal to 6x. So from here, I'll just solve the equation. I won't add 2. I lied. Leave that there. I'm going to subtract 4x. So I get negative 2 is equal to 2x divided by negative. Sorry. It's actually still pretty early. So my brain isn't firing all cylinders 100% yet. So divide by 2, divide by 2. So then we get x equals negative 1. There we go. So it's as simple as just making the bases the same and then setting the exponents equal to each other and solving. Alright, so we have Tatiana starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. So first part, we have to write an exponential function that can be used to model the number of bacteria after X hours if the number of bacteria changes at the same rate. So we start at 7,500 and we're going up to 23,000. So this is a growth model. So we can use our standard formatting for an exponential function, y equals a times b to the x. Alright, so some of these pieces. So a is our initial amount. Y is our final amount. And b is our growth factor. And x is time. Alright. So over here, my y equals 23,000, because that's our final amount. My a equals 7,500, because that's what we started with. And b is unknown, but x is 4. Okay. So we have 23,000 is equal to 7,500 b, well, not to the x because we know x, b to the 4. So to figure out our growth factor, which is the important part of exponential functions, we have to solve this. Solve for b. So I'll divide by 7,500. And then we get 3.06 is equal to b to the 4th. Take the 4th root. Okay. Another way to look at that is 3.06 to the 1/4 power. Alright, these are the same. Oh, that's cubed. Alright, they're the same thing. So it depends on how you put it in the calculator. So then I get b is equal to about 1.32. I'm rounding to 2 decimal places. So our formula, y equals, our starting amount of bacteria is 7,500 times b, which is 1.32, to some time. Alright, so to use our projection model, we're going to use this. Now you can do this one of two ways. You can put it in Desmos and pull up the table, or we can just plug in 12 for x. So y equals hammer it on the calculator exactly like this. Use lots of parentheses. So after 12 hours, we will have 209,869.07 bacteria. Alright, so use your standard model, y equals a times b to the x. You have your, over here on the right, what each piece means. And then you just solve for the missing piece, and then you just got to go back and plug in time. Example 3 is a banking style problem. Alright, so we have an investment account pays 4.2% interest annually, and it's compounded monthly. If $5,552 is invested in this account, what will the balance be after 15 years? Okay. So we need to figure out what everything's going to be. So our amount is A, our final amount. P is our principal. And R is our rate. N is the number of times compounded. And then T is time. So we don't know our final amount. Our principal is $5,552. Our rate is 4.2%, but you want to make it into a decimal. So slide it 2 to the left. It's 0.042. It's compounded monthly, so that means it's compounded 12 times per year. And our time is 15 years. So now we just need to plug in and solve. So A is equal to 5552. 1 plus 0.042 over 12. And then it's 12 times 15, n times t at the top. So A equals 5,552. Put in the parentheses in the calculator, you get 1.004. 12 times 15 is 180. Alright, and then I'll slap another set of parentheses on that. So multiply that. And after 15 years, you will have a whopping $11,389.84. Alright. So solving our inequalities is just like solving our equations. I'm going to have the same base. Alright, so I have 16 and I have 8. So as I said, let's start with the lower one. So I have 8 to the 1 is 8. 8 squared is 64. That is vastly bigger than 16, so I can't use 8. 8 does not work. I know they're both even, so let's start with 2. Alright, 2 1 is 2. 2 2 is 4. 2 cubed is 8. 2 to the 4 is 16. There we go, we have it. So 2 cubed is 8, and 2 to the 4 is 16. Substitute those in for 16 and 8. So 16 is 2 to the 4. 2x minus 3 is less than 2 cubed. Power to a power property, so I'm going to distribute that 4. 2 to the 8x minus 12 is less than 2 cubed. I have the same base now. So I ignore the base and just set the exponents equal to each other and solve. Add 12. So 8x is less than 15. Divide by 8. X is less than 15 eighths. You can leave it as a fraction, or you can make it into a decimal. Doesn't matter. Okay. This one's a bit tricky. Alright, so we have a fraction here. We have to flip the fraction. Okay. So I get 3. 2x minus 1 is greater than or equal to 243 to the negative 1 power because I flipped it. So lowest base is 3, so let's do 3. 1 is 3. 3 squared is 9er. 3 cubed is 27. 3 to the 4 is 81. 3 to the 5 is 243. We got it. So we're going to substitute that in for 243. So 3, 2x minus 1 is greater than or equal to 3 to the 5 to the negative 1. So power to a power, you get 3, 2x minus 1 is greater than or equal to 3 to the negative 5. Drop the bases, solve the exponents. 2x minus 1 is greater than or equal to negative 5. Solve the inequality. X is greater than or equal to negative 2. And that's what we have. So solving exponential equations. Just find the toughest part's finding the same base. Alright, so you want to use your 2's, your 3's, your 4's, and your 5's.